recording on my iPhone.
Absolutely real. Next. Oh, do I move it or?
I will.
Okay. Oh, thanks. So this is the climate clock in New York, and it's just a sign of our times. It is actually telling us in this specific screenshot, which was taken in September, that we basically have 7 years, 103 years, 103 days, so on and so forth, before we absolutely hit the limit on reversing, taking drastic action to reverse where we are going with climate change. There is urgency. It is serious. And at this point, we have to dig deep and try to move forward on all sectors. Next. The link between the built environment and the global carbon emissions is a powerful one, as we know as architects, with 40% of the emissions derived from the activities in the building and construction sector. 11% alone is from materials. And we can achieve 65% reduction in our, if we can achieve 65% reduction in our global carbon emissions, we can begin to reverse this process. Next. Oh, I skipped it. Okay, so this is, no, it's my fault. I went too fast. But basically, again, we see here the 40% emissions that are being emitted by the built environment, and it clearly indicates the role that materials have to play. Next. Inevitably, what we have come to understand is that at this point, to achieve carbon neutrality, we really have to look at not just operational carbon, but also embodied carbon. And as buildings are becoming more efficient through the use of renewable energy and efficient renovations, building materials are becoming very, very important. We have to pay close attention to what we are specifying. Next. Next. Oops.
Sorry.
Oh, no, sorry.
Sticky.
as I bark. Again, we have to, the point of my reiterating this, that embodied carbon is about material selection and the manufacture of materials. And more than ever before, this is playing a greater role in carbon reduction strategies. Next. So the great challenge in reversing the effects of climate change demands that really we look beyond the traditional life cycle of materials, and that we reframe our material choices to not only promote reuse, but also look for innovation. Next. So what does this mean? This is the whole embodied carbon cycle. So the next 3 slides should sort of move consecutively. We will see that this illustrates how our current model really has been based on extracting materials thoughtlessly for short-term use and assuming that they're going to be discarded. Next. This is upfront carbon. This is the very beginning when we extract the raw materials, we specify and we build. Next. Renovation, maintenance, and repair. Next. And disposal. This is where we are. We take, we make, we waste. Next. Again, here what we see is an example of what the end product is: the extraction, the processing, and the use. This is an unsustainable path that we are on. We are way past trying to balance need with resources, and it has to change. Next. In contrast to what's called the linear system, we are trying to promote and make a transition to the circular. Here are the 3 goals that have been promoted by the Ellen MacArthur Foundation that are really driving so much of the important change that's happening in the world. There are about 29 definitions of circularity in the world today. Some of them are more financially based. It depends what sector you're on. But this is the one that we need to look at because it really talks about the 3 critical components, which is the environment, the economy, and the social piece. Next. So how do we connect all the dots between linear, zero waste, and circular? The beauty of the zero waste values and policies is that they aspire to make these changes by minimizing waste and reuse. But the circularity takes it to the next level, where we acknowledge that we really have to reshape our practices in a financial way, that our choices have a financial impact, and we have to think about how we make things, how we sell them, and what it means. Next. So now we're going to talk a little bit about the construction and demolition waste stream. This waste stream is very unique, and it's frequently misunderstood. It really represents the convergence of three critical issues of our time. Again, the environment and the resources, economic viability, and the ramification, the impact of our material choices on human health. It is predominantly, overwhelmingly, a glaring example of material waste in our culture. And yet, it still offers a framework for reversing the trends that we're on. Can we harness all these materials and all this waste to be resources? Can we celebrate the fact that it's offering jobs or opportunities for employment and opportunities to protect human health? Next. The CMD waste stream includes many materials. It's wood, it's plaster, drywall, asphalt, bricks, block, unsegregated concrete, building components, trees, stumps, rocks, and systems, all of which are coming all the way from the initial construction to demolition. So in essence, this waste stream is reflecting the building's life cycle. Next. And this is, in case you can't tell by the pictures, it really is a vast, messy waste stream. And it can be hard to capture individual materials for use, even with this kind of sophisticated technology. These machines are unbelievable. There are usually fragments and remnants and all these little pebbles that are known as fines that are missed opportunities. Nobody knows what to do with them, and they end up being used for soil amendment or landscape treatment. Next. What we know is that in order to increase the likelihood of materials being used, of being salvaged, two things are essential. One of them is to segregate them at the point of generation at site. And then really, and this is the harder part, is to make sure that there's an end market for these materials. Because if there isn't a market, all this stuff goes right to the landfill. Nobody even questions it. They can't make money out of it, so it's just garbage to them. And that's part of the problem. Next. So this is an interesting graphic from a waste report here in the city of Philadelphia. It shows that the CMD waste stream is separate from solid municipal waste, which is daily garbage, right? Office garbage, the garbage we create in our homes. And the most interesting part about it is that it shows that really we shouldn't really pay too much attention to the CMD waste stream because it only represents 8% in terms of its emissions. Well, is that really true? One of the things that we also know about the CMD waste stream is that historically it has been very poorly monitored, both at the national and the local level. It's poorly documented, and in Philadelphia, we don't even have we don't really have ways to make people sort of responsible for it. The city doesn't control the flow of privately collected material. It allows private haulers to just take the material away without any specifics. The most interesting thing too is that in the city of Philadelphia, there is a huge zero waste campaign, but they left out the CMD waste stream. So it's almost like it's there, but it's not there. It's completely unregulated. Next. these statistics, again, reflect a level of, how can I say, lack of credibility with some of the numbers that are driving the C&D waste stream locally. And by that, I mean that if you look at this carefully, what they're saying is that we actually have close to a 90% recycling rate with C&D materials. That's simply not possible. It's simply not possible. And when you consult people who are in the business, this is explained by saying, well, we're trying to sort of tidy up our representation of this waste stream. Next. So all of this is to say that it's very hard to rely on some of these numbers and make the statement that it doesn't matter, C&D waste, it can't be harnessed and changed for the benefit of its impact to greenhouse gas emissions. Next. When we look at statistics that are put forth by the EPA, we get a little more perspective. It clearly shows that across the US, regardless of what we think is happening in Philadelphia, the vast majority of these materials are going to the landfill. And that is really, it's terrible. These materials will rot in the landfills. They will contaminate the air and local waters and frequently poison the area where the workers are. It is very destructive to human health, and it's a huge loss in terms of resources. Next. So what we need to do, obviously, is try to figure out which of these materials can we hone in on to try to seize them for reuse, for innovation. Not all materials are the same. We know that concrete, steel, and aluminum generate the most carbon emissions. And ironically, concrete is shown as having, as you can see, the greatest reuse. Wood and drywall, almost regularly go right to the landfill. Next. So when we think about material circularity, we're not just saying reuse, we're really saying transformation. What are we going to do with all these materials? How can we go from a linear system that is based on waste, disposal, cheap materials, to something that is more regenerative? Next. Drywall waste is actually, as we know, the most ubiquitous of the interior materials. And it's used extensively, in construction, renovations, for fire safety, laminations. It's not that it has enormous carbon intensity, but its sheer volume is significant and warrants a second look. Next. Every year, 13 million tons of gypsum wallboard debris are generated in the US, and 85% of this goes right to the landfill. Why does this happen? Well, the reasons vary. Some of them are cutoffs from installation, damaged boards, and over-ordering. There are many reasons. Next. As I said, drywall itself is not carbon intensive, but the manufacturing process really is. And the gypsum itself, which is mined, so it's a natural resource, makes up 90% of the weight of the drywall and is recyclable. The paper exteriors can also be made, you can see them there, from recycled materials, but the manufacturing process sometimes neutralizes these benefits, any of the energy saving benefits. Next. Today, we have the carbon calculator, this miraculous tool that allows us to perform life cycle analyses on a variety of products. Drywall manufacturers are creating their own EPDs, environmental product declarations, so they can essentially promote their materials for their environmental benefits. And architects can select and deselect these, competing against price and what they can do for their projects, right? Next. For the first time, and this really is an innovation in the drywall industry, there is the ASTM standard C1881, which is going to allow the industry to start making brand new drywall by integrated recycled materials into their processes. This is a rare example of closing the loop. This is what circularity means. It's not necessarily discarding the material, but simply reusing it, integrated into a new product that is recognized in the industry for its integrity and use. Next. Wood waste. In 2017, 3.3 billion tons of wood waste were generated during construction and demolition activities. Its treatment at the end of life can have a major impact on carbon emissions, especially if it ends up in the landfill. Next. Wood remnants include dimensional lumber, engineered wood products, posts, poles, and even tree parts. The majority end up recycled as mulch, pellets, or animal bedding. Why? Because these are lower value markets. In the current model, the linear model, unless there is demand and price, we cannot make these a commodity. Price dictates what gets recycled. Next. So in the wood industry, the first step is always to segregate the wood remnants and make sure that nothing that is treated with chemicals or creosote is in there, because they can't be sold to manufacturers. Nails, glue, and metal attachments also hinder this recycling process. Next. And depending on the quality of the recovered pieces, some of them may get selected for high-end use, maybe for a beautiful table. And I guess this is a form of circularity, but it hardly solves or offers us an opportunity to transform practices. That's a very unique example. Some of the pieces may be remanufactured into new wood products, such as MDF or particle board. But again, the manufacturing process, and with the pressure, the heat, and the adhesives, can make the new product more intensive than the sawn lumber. Next. Wood is really a remarkable product, and there's enormous innovation, especially in the development of structural members. As you all know, a cross-laminated timber made with layered boards competes in strength and span with concrete and steel, although, again, wood is in a class all itself as a renewable material. Unfortunately, structural applications of wood lag in terms of documentation for environmental product declarations. As we know, the EC3 tool, the carbon calculator, is performing life cycle analyses that really are transforming how we specify products and how we build. And they allow us to make comparisons between specific products, their carbon and their pricing. The EPDs are the entry point into the life cycle analysis, but they really don't exist for most recycled products. And that is holding back the process of circularity. For now, what they have, the EPDs that are on the calculator, are really focusing on new dimensional lumber and sheets, boards, engineered timber, and wood pine joists. Again, there is little progress on including EPDs for structural members that have a recycled content. Next. So how do we begin to convert the use of the carbon calculator so that it measures waste in materials. Next. This is a snapshot of the life cycle here in its entirety. And the current EPDs that we can access through the Carbon Leadership Forum really focus on new products. That's A1 through A3. Waste materials are those that have been deemed end of use. So we're kind of struggling here to quantify waste. What is the energy content of these materials? There's something called WARM, the waste reduction model, that is developed by the EPA that is trying to quantify this. I mean, they're theoretical numbers, but it's a starting point. Next. And this gets very wonky, and we won't get into the specifics of it, but they create these artificial formulas that are directed to the materials you see below on this slide to help us process trade-offs. You know, what happens if we divert something to the landfill? What's being saved? What other alternatives are there? Next. I find this absolutely fascinating, where they actually have formulas that quantify, again, theoretically, such things as economic benefits, jobs. We're not just looking at acres saved from landfilling, but sort of socioeconomic ways to evaluate waste materials. This is a starting point. They also have a product called the Recon tool, where the idea is that we are factoring the embodied carbon, the greenhouse gas emissions associated with waste materials, but they don't really have them yet for building materials. Next. So we need to ask ourselves this circularity. How does this really, what are we supposed to do with this? How can we move forward this? How can we push this forward? Next. In light of the fact that projects at the municipal level, at the government level, are now promoting procurement guidelines where they specify that they need EPDs for 75% of materials with a limit on global warming potential. And very frequently they require life cycle analyses so that buildings can be designed to prove that the materials selected offer a significant reduction in carbon. There is a growing demand that we as architects can begin to meet as we design and interface with these municipalities. Next. There are many, many things happening with materials, and they're moving so quickly that it's hard enough trying to learn them and understand them. The process of change is huge. Materials passports is really more for projects that have been digitized. It's the next wave. Overseas, there's something called buildings as material banks, where they recognize that buildings are repositories of materials. And they're promoting sort of this codification of material qualities into one place so that that information, which is a code, travels with that product in its new installation. It's fascinating. It connects drawings, specifications, and at least the way they're thinking of it overseas, it's all in one location, hence the idea of a repository. We have, EPDs, health product declarations, environmental product declarations. Do we have one single repository? No. It's all changing very quickly. I'm not sure where this will lead, but I believe that as we get more involved in assigning global warming potential to products, this is something that we might benefit from. And to make sure that we can track materials and make sure that they can be reused, and when they are transformed, that we can track that evolution. Next. This might be seen as a pipe dream, I don't know, but it's always good to have goals. One of the things that many cities are doing is emphasizing the role of deconstruction, because when we are able to extract materials in a careful way, that they are more likely to be reused. So that's what this means, deconstruction rather than demolition. The mechanical removal, the abrupt removal of materials tends to mean that we destroy a lot of potentially reusable materials, which is what the statistics show in terms of waste collection. They said that 90% came from demolition, you know. So these are things that we can begin to specify and require in Division 1. There in Philadelphia, you'll be seeing in September, we have Nick Esposito and Greg Trainer, who are involved in circularity in Philadelphia and using it in a way to regenerate neighborhoods. I mean, it's a very powerful thing. They're training people to learn how to deconstruct buildings. It's giving people jobs. It's really securing buildings that are profoundly sometimes dangerous because they're unstable, and they are gleaning the materials and selling them. And so all of this continues to create a loop of activity that defines circularity. What else? So material innovation. I didn't know if I'd have time to say this. I know that there's very little time right now, but there will also be people coming to speak, like Amanda Kaminsky, who is with the Eco Products building system, where they're really innovating with materials, with drywall, with concrete. And part of our role as architects is to push this forward, to keep asking for it and insist, you know, that these are the new standard. It ties into this idea of material banks, and hopefully between digitizing drawings and using this as a way to track things and our own practices, we will eventually go from a linear to a circular model. That's it.
Thank you, Daphne. I really appreciated your presentation. I have a ton of questions.
Yes.
I'm sure others do too. But for the sake of time and so that we can get through updates from all of our subcommittees, I'm going to ask that people drop them in the chat and continue the conversation with Daphne to make sure that we're able to continue the conversation. So I'm going to jump over.
Daphne, thank you so much. Even though I couldn't see it, it sounds like it's an immense amount of research that has been done, and thank you for all that.
Oh, thank you. My pleasure.
I look forward to watching the video later.